right, let's go ahead and get started. Welcome, everyone. Thank you for joining us today. This is our monthly webinar series. For all you regulars out there, this is a partnership between the Tennessee Urban Forestry Council and the UT School of Natural Resources. I'm joined today with Katie Donaldson from the UT School of Natural Resources, who also puts a ton of effort into this webinar series. We are missing our host today, Imagine Shaw. You've become accustomed to seeing her friendly face welcoming to these calls. She's out in the field today, but I'm sure she'll catch the recording and misses seeing everyone here. I'm really excited today because I've been able to see this project a little bit from beginning to end with the city of Clarksville and their partnership with the NASA Develop program. And so we have with us Kathrine Killebrew, who's the city forester with the city of Clarksville, as well as representatives from the NASA Develop program, Betsy Hernandez, a research associate with NASA and UAH, Drew Emerine, NASA Develop Spring and Summer 2025 researcher, Tana Gobble, also a Spring and Summer 2025 researcher, and then Christina Villalobos, the center lead with NASA Develop. So we have a packed agenda going over two projects that NASA Develop did with the city of Clarksville, one on air quality and heat, and the other on stormwater management. And for anyone here in the Tennessee area, a lot of people are moving here. There's a ton of development pressure on our cities and cities like Clarksville in particular. And that means that the tree canopy loss is certainly happening and having an impact. And so NASA Develop being a fellowship-based program where these participants applied to be admitted into this program and participate in these studies, used Earth observation data to figure out what's going on the ground so they can drive decision-making and planning and action for urban forestry in the city of Clarksville. So with that, I will first hand it off to Katie. She's going to go over CEUs and some basic housekeeping, and then we'll get started.
All right. Thank you, Kevin. I'm going to share my screen. There we go. Okay. So if you are seeking ISA CEUs or SAF CFEs today, please make sure that you have registered and that you've paid the $10 fee and that your full name is showing, or the name that you used when you registered, that it is showing on Zoom so that you get credit. That just makes it easier for us whenever we go back and look at everyone who has signed into this webinar. And that way we can use your name and send it to ISA or SAF. If you need to change your name, you can go to the Participants tab, click on the three dots next to your name and hit Rename, and you can change it to the name you used when you registered. If you are a general attendee and you do not want ISA CEUs or SAF CFEs, you do not have to worry about paying the fee. If you're a TUFC member, you also do not have to worry about paying the fee. At the end of the webinar, we will also put up a QR code that, again, that just makes it easier for us to determine who is seeking those ISA CEUs and SAF CFEs. Also, during the presentation, if you have any questions that you would like to ask, we do have a Q&A portion at the end of the presentation, and you can enter your questions in the chat. So, Kevin, I think that's everything from my end.
All right. Thanks, Katie. With that, I will pass it on to the NASA Develop team, and I think Christina is going to kick it off for us.
Awesome. Yeah, let me go ahead and get these slides ready. All right, everyone. Thank you for having us today. We're very excited to show you more about the work that our participants have worked on within these 2 terms and their 10 weeks within the program. Kevin already did such a great job summarizing the Develop program, but I do have a couple slides prepped here to further explain what the Develop program is. So Develop bridges the gap between NASA Earth Science and society. In the lower right-hand corner, you'll see Earth Action. So NASA Develop is part of the Earth Action program under capacity building. And in this slide, you'll also see that we bridge that gap by building capacity in both the participants, so like Tana and Drew, who you will hear from in a second, and the end user organization. So in this case, that would be the city of Clarksville. We do this because satellites, they're taxpayer funded. We want to make sure that people are getting their use out of them. They are an amazing resource. They are readily available, but most folks don't know about their existence, how to access them, how to apply them. And so that is where programs like NASA Develop come in to help bridge that gap, to help folks learn how to utilize NASA Earth observations for their decision-making needs. Our projects are 10-week terms. They fall under one of the 9 categories you see listed down there. So in this presentation, you will be hearing about the Health and Air Quality Project and a Water Resources Project. And Develop is very unique in the sense that we are a 10-week program. Our participants are very zoned in, very focused, and very dedicated to the project in their 10 weeks. They are all here to, again, as mentioned in the previous slide, build the capacity. And so we do that. We help build that capacity building by having NASA scientists and partner organizations readily available to advise these projects. In these projects, there are handoff products that go to the partner organization, which means that we will create a sort of resource or data or analysis that the partner will then use for their decision-making needs. And throughout the project, teams also create a consistent set of deliverables. So they will develop a poster, presentation, and technical report, all of which detail the team's methodologies that they took to get to the end products or the end result. And a lot of people are always curious about the 10-week timeline because it is fairly quick. And here we just have our ideal timeline within these 10 weeks. Our participants also have various deadlines in between to make sure that they are steadily progressing through the deliverables and making sure that by the end of the 10 weeks, we have quality deliverables that will aid in our partner organization's decision-making needs. And when Kevin and his team invited Develop to be a part of this webinar, this was a couple months back. It was very exciting to be a part of this webinar. One of NASA's core values is service. We are here to serve the public, to serve everyone. And NASA Develop was a prior resource. Unfortunately, it is no longer going to continue. But with that, I would like to pass it over to Betsy Hernandez because she does have some land surface temperature related resources that she would love to share about. Despite some programs not surviving the administration, we do have subject matter experts within the NASA realm, within the UAH realm, who have a lot of resources and want to serve the community and serve the public. So again, I will pass it over to Betsy to talk about some land surface temperature resources.
Thank you very much, Christina. I'm going to turn also off my camera just because of the bandwidth, but yeah, thank you very much. My name is Betsy Hernandez. I'm a research scientist from the University of Alabama in Huntsville. I support different, can you go back? Back? Yeah, thank you. I support different initiatives at NASA Marshall Space Flight Center. I have been working with Earth observation data for almost 20 years. And it's a pleasure to be here, and thank you for the invitation. Also, congratulations to the Tennessee Urban Forest Council for this initiative to inform the public about these relevant topics. So next slide. Next slide. Yeah. So according to the 2020 census, about 80% of the U.S. population lives in urban areas. Right now, 50% of the global population lives in urban areas, but there is a projection that by 2050, there will be 68% of the global population living in urban areas. So as urbanization increases, more people are affected by the urban heat island effect, whereby urban areas trap heat, becoming much more warmer than their surroundings, so with adverse health consequences for inhabitants. So the World Bank developed a heat risk assessment with different future scenarios and the relation to the increase in population. The data is good for reference, but not necessarily for urban planning to provide a general indications of parts of the cities that might be more vulnerable to heat risk. So as you can see in the left graphic, the World Bank projects that the east of the US will be more impacted by extreme heat. Next slide. Yeah, so this is an analysis from 10 years ago. Shows the difference in temperatures between the urban areas and vegetated land. As you can see, the majority of the cities in the US are about 2 degrees hotter than the nearby green areas. Next. Yeah, so in this graphic, you can see that there is a relationship between the impervious surface and the increase in the land surface temperature. Next slide. So it's also worth noting that the data from Earth observation satellite sensors like the MODIS, VERS, facilitates daily monitoring of the land surface temperature, but this is especially useful for areas where there is no availability of in situ measurements. Next slide. So here is an example of the city in Paris, France. Land surface temperature was analyzed before the last year Olympics. Next slide. Yeah, so the data show substantial difference between the impervious surface and the green areas. This analysis was done using land surface temperature data from beers, taken around 1:30 p.m. local time. Next slide. So this is another interesting example from the city of Los Angeles. So LA City Sustainability Office implemented a cool pavement pilot project to mitigate the effect of extreme heat. So with the help of NASA JPL and the land surface temperature data derived from the EcoStress, which is a sensor located in the International Space Station, they were able to evaluate the efficiency of the cooling mitigation activity by looking at how the reflective street paint lowered the surface temperature. Next slide. Yeah, so here is an example of Clarksville, Tennessee. So based on the city climatology, we can see that the hottest months of the year are between May and September, with being the hottest between 10 a.m. and midnight. We can also see that there are sensors that can help us to monitor the city's land surface temperature. Both MODIS, Aqua, and BEER sensors image the city in the early afternoon, so during the peak heat. It's about 1:30 p.m. Next slide. So if you are interested in visualizing the daily land surface temperature data, you can check out the NASA World View, as I'm showing here in this example. In this first image, you can see the city in yellow using nighttime lights data from the BEER sensor. Next. Yeah, so with the MODIS Aqua image from 1:30, from this is an image from the past Monday. You can also see that the cities are hotter than their surroundings because of the urban heat island effect. So as we can see in the red colors. It's also important to note that the land surface temperature data can be affected by cloud cover. As you can see, there are areas where we don't have data because of the clouds. Next slide. Yeah, so in closing, if you are interested in learning more about how to take advantage of the satellite data to monitor urban heat island effect, I would recommend checking the following 2 trainings offered by NASA Applied Remote Sensing Training Program, ARSET. And all of the materials from the webinars, including the slides, videos, and scripts, are all openly available. Also, ARSET regularly offer new trainings courses of different topics. So if you take the course when it's original offer, you can also get a certificate upon successful completion of the each course. Next slide. So that's all I have. Thank you. Thank you, Christina.
All right, awesome. Thank you, Betsy. Sorry about that. Okay, next we're going to go into the Clarksville Health and Air Quality Project. So I will go ahead and pass it over to Tana to present on the results.
Hi, thank you, Christina, and hello, everyone. I want to thank you guys again for attending. I'm Tana Gobble, and I'll be presenting the Spring 2025 Alabama Marshall Nodes project presentation. The project's titled Clarksville Health and Air Quality, Assessing Urban Tree Canopy to Inform Heat Mitigation Strategies in Clarksville, Tennessee. The work for this project was completed by, go back, sorry. Wrong way.
I'm so sorry. It like is continuing instead of going backwards.
It's okay.
Giving everyone a sneak peek. There you go.
Okay. Thank you. The work for this project was completed by me along with Bryce DiNardo, who was a huge help with the land surface temperature, Chris McEnvoy, who did a lot of the planet scope work, and Aubrey Dolbeck, who was our team lead and just kind of did a little bit of everything, all of whom unfortunately couldn't be here today, but I wanted to recognize everyone and their amazing work nonetheless. Okay, we can go into the next slide. Okay, so our health and air quality project focuses on the city of Clarksville, Tennessee, which is located near the Kentucky border within Montgomery County. Clarksville is one of the fastest growing cities in the United States with a population of over 180,000 in 2023 and a growth rate of about 22% from 2015 to 2024. Clarksville, Tennessee has an humid subtropical climate type experiencing hot and humid summers with 70 days over 90 degrees experienced in 2024 and cool to mild winters averaging below 55 degrees and a range of precipitation. Next slide. Okay. In the past 7 years, Clarksville's tree canopy has reportedly been reduced by 50% due to rapid population and infrastructure growth. The city is currently concerned about the state of their urban canopy and that such a drastic loss, plus an increase in anthropogenic activities, may have resulted in an exacerbation of the urban heat island effect within Clarksville. The consequences of which are also a concern. Increases in urban heat could result in the community suffering from more high heat stress days every single year. As mentioned previously, in 2024, the city recorded 70 days with temperatures greater than 90 degrees Fahrenheit. This is a significant increase from only 33 to 59 days from 2015 to 2019. Days exceeding 90 degrees are classified as extreme caution to extreme danger days depending on humidity by the National Weather Service. This suggests a higher risk of heat-related illnesses, which is especially worrisome considering the community's elderly population. Okay, next slide, please. So to address the concerns of our partners, we devised 4 main objectives. The first is to assess change in Clarksville's urban canopy through the study period. We also identified land surface temperature variation throughout the city and assessed the urban heat island effect in the city. Finally, we explored which areas in Clarksville would benefit most from restoration efforts. Next slide. So to do this, we use Landsat 8 and 9, both TIRS and OLLI, to provide daytime land surface temperature and normalized difference vegetation index, or NDVI. Also to aid in NDVI, we use Planet's collection of satellites called DOVES. Finally, with the use of the ISS EcoStress system, we assessed nighttime land surface temperature data. Okay, next slide. All right, so now I will go into the results and conclusions of our project. Next slide. Okay, so NDVI, or Normalized Difference Vegetation Index, is a way to quantify plant health and density by measuring its greenness. To calculate NDVI, we obtained 30-meter resolution imageries from Landsat 8 and 9's OLLI sensor data. With this data, we were able to use the near and red bands to calculate how green each Landsat pixel was. We then made a single composite image displaying the 90th percentile NDVI of the months May through July for 2015 through 2024. NDVI values range from -1 to +1. Quantities less than 0.1 are typically areas with no vegetative cover, while 0.7 to 0.9 and up represent areas of dense vegetation such as forest canopies. The time series indicates the areas of lower NDVI, the red areas, are concentrated in more urban areas, and they intensify as time passes due to increased development and loss of tree canopy. The increases in development can clearly be seen as these once green areas transition to yellow or red with time. Okay, next slide, please. All right. The 90th percentile NDVI difference quantifies vegetation change between 2 years. Major, minor, and no change increases and decreases between 2015 and 2024 are visualized on this map. The NDVI difference map indicates substantial decreases in vegetations in various locations, with the greatest change being approximately negative 0.47 near Simpson Lane. Some major increases can also be seen in forested areas along the city, with the greatest change being approximately plus 0.36 along E Boy Scout Road. Okay, next slide, please. All right. Using PlanetScope's data, we were able to process and make a time series of NDVI from 2018 to 2024. Planet's high-frequency satellite imagery gives higher spatial resolution, which is 3 meters, compared to Landsat imagery, which is 30 meters. For the purposes of NDVI, it provided a more accurate tracking of vegetation health and changes over time, allowing for the identification of finer details within the study area. Heavy canopy loss was experienced in neighborhoods such as Wingate, Swan Lake Village, and St. Bethlehem. Next slide, please. All right. NLCD data was also leveraged to visualize Clarksville's canopy cover in relation to citywide land use. Its impervious surfaces and cultivated crop cover made up the majority of the city, with smatterings of canopy cover in city parks, public green spaces, and undeveloped land. Results were gathered from 2011 to 2021 when the data was last available and showed notable differences in canopy cover in neighborhoods of Wingate, Woodlawn Estates, Swan Lake Village, and St. Bethlehem. These findings can be used to inform future policy for tree planting sites and restoration efforts. All right, we used Landsat 8 and 9 tiers to determine daytime LST throughout the city of Clarksville. In 2024, select parts of the city reached temperatures as high as 125 degrees Fahrenheit between the months of May through July. Based on visual comparison between just 2016 and 2024, Clarksville has experienced a rise in temperature, which could be due to the increases of housing developments throughout the city and the loss of vegetation that comes from that development. Okay, next slide, please. Okay, so the daytime LST difference map utilized median composites to visualize how the temperatures of different areas in Clarksville have fared from 2016 to 2024. Here, shades of red signify areas of warming within the city, where blue tones showcase areas where land surface temperature have cooled since 2016. And as you can see from this map, there are a lot of areas where you can see major warming or even down slight warming, and very few areas are experiencing cooling. Next slide, please. Okay, so this map allowed us to conclude that often the parts of the city that are hottest during the day are still the hottest at night, respectively. By looking at the nighttime land surface temperature change, we can see that from 2019 to 2023, a lot of the areas are experiencing warming as a result of development and an increase in impervious surfaces. Many of these areas are unable to cool down because of the urban heat island effect as a result of this development. Okay, next slide, please. Though there is a clear rise in temperatures in Clarksville between the years of 2016 through 2024, it's important to understand if this high LST is a result of the urban heat island effect. To determine this, we sampled a rural town outside of Clarksville called Woodlawn to be used as our reference LST. An area that is presumably unaffected by the urban heat island effect because it's a very green, small area. We then compared the average land surface temperature of this reference area in 2024 to the Clarksville's 2024 land surface temperature to determine how much warmer or cooler Clarksville is than the rural counterpart and if the urban heat island effect is at play within the city. Our results show that nearly the entire city of Clarksville has a higher temperature than the average land surface temperature of our reference area. The values in the map to the right are a comparison between Clarksville's median LST and Woodlawn's median LST and range from 20 degrees to 32 degrees Fahrenheit. Values are a comparison between Clarksville's median LST and Woodlawn's mean LST. Woodlawn is a rural town near Clarksville, which we used as the reference area. And you can see that along like the major development areas like downtown and then along major roadways, you can see that it's significantly warmer than Woodlawn is across the area. So, next slide, please. Okay. So to synthesize our results of land surface temperature, NDVI, and impervious surface cover, we created a restoration priority map that shows which areas in the city are in the highest need of restoration efforts. As expected, highly developed areas such as downtown Clarksville, developments along city highways are those that would benefit the most from restoration areas where many housing developments are only in moderate need of environmental improvements such as tree plantings. Next slide, please. However, restoration efforts within a city shouldn't be purely driven by environmental factors. There should be some consideration of the ability of the community to handle negative environmental conditions. The map on the right considers this social element. So we took the 2022 U.S. Census Bureau Community Resilience Estimate, and we took that and combined it with our environmental restoration priority map to see which areas would benefit the most from planting trees based off of the socio-environmental factors. We found that still downtown Clarksville area kind of is in the top priority, but areas around like Hampton Station, Outlaw Field, those sort of areas are also very high priority. So it just kind of added another factor to be considered when planting trees. Next slide, please. So our two main sources of error came from limited availability and quality of data, especially land surface temperature. Both Microsoft Planetary Computer and APIERS had low quantities of images for specific years. This resulted in some of the year's composite maps with data gaps. The quality of the data is also a possible place for errors. Landsat and EcoStress do not have the best spatial resolution, and as a result give a more generalized output of an area rather than a single location within the city. In that same vein, the city does not have living records of land surface temperature measured on site, giving us the inability to measure ground truth of land surface temperature values. Finally, with using Earth observation data, cloud cover is a great place for errors. While we did apply cloud masks and hopefully had enough images without overlapping cloud cover to have a meaningful result, we did have a few daytime and nighttime land surface temperature images that had pockets of no data, which provided incomplete results. Okay, next slide, please. All right, so all of the products that the team has created can feasibly be used in Clarksville's future planning decisions. PlanetScope is likely the best Earth observation tool for future use due to its high resolution. However, this data is not free to access, which poses possible accessibility issues, which is where products from Landsat could kind of come in and help out. So I'll let Kathrine come in and speak about the partner implementation.
Hello, in reference to the partner implementation, all the products that are going to be delivered by the development team will be used with the city of Clarksville and Tennessee Urban Forestry Council, and basically to assist in making informed mitigation decisions, particularly on tree planting locations, to help alleviate the urban heat, is what we're trying to do.
Okay. Thank you, Kathrine. And then for our conclusions, our study brought the team to the following conclusions. The urban heat island effect is present in Clarksville, and surface temperatures are higher in urban areas than their suburban and rural counterparts. Vegetation density and health is likely affecting the urban heat intensity. And finally, normalized difference vegetation index, land surface temperature, impervious surface cover, and canopy cover all may be intertwined to this urban heat island effect. The various products we created hold value and may prove crucial to inform future urban tree planting efforts. Next slide, please. All right. The team would like to thank our partners, the City of Clarksville, and the Tennessee Urban Forestry Council, our science advisors, Dr. Africa Flores Anderson and Dr. Sy, and our lead, Cristina Villalobos Heredia.
All right, awesome.
Thank
Thank
you.
you so much, Tana, and Kathrine, for speaking on the Clarksville Health and Air Quality Project. This project was really great to just have that collaboration with Kathrine and Kevin. And we found, I guess, need for a second project. This project being the Clarksville Water Resources Project. And what I mean by need is simply there was a question and we had the Earth observations and some resources such as the INVEST model, which the team will go into in this presentation to be able to apply to a second term. So with that, again, I will pass it over to Tana and Drew to present on the Clarksville Water Resources Project.
Thank you. And hi again. I'm Tana Gobble, as you all know, and I'm here with Drew and Ryan, and we're going to be going over the Clarksville Water Resources, assessing flooding susceptibility and urban canopy efficiency as a stormwater management mitigation tool. This project was completed by the two of us, along with Sam Alden, who worked a lot on the damage, built infrastructure, and custom watersheds, and Jessica Pham, who worked a lot on the tree canopy. They unfortunately couldn't be here today, but once again, I really wanted to recognize my coworkers and give them the credit that they deserve for this project. Okay, next slide, please. All right, so this continuing partnership with the City of Clarksville focused on flooding and falls under NASA Water Resources Application Area. Clarksville has a humid subtropical climate type, as was previously mentioned, and an average rainfall of 50.96 inches annually. Despite this development, the city maintains an estimated of 5,162 mixed species trees. Furthermore, due to grant funding, Clarksville has planted over 40 trees this year, which is amazing. Next slide, please. Okay, so as mentioned before, Clarksville's grown significantly in the past several years. This has resulted in necessary development to accommodate that growth, and that's led to more impervious surfaces. Clarksville is currently losing tree canopy cover to make room for these new developments. Higher impervious surfaces combined with this loss in canopy results in higher runoff, leading to stress on stormwater systems like drains during heavy rainfall. This stormwater can cause significant damage to property. Next slide, please. So to address these concerns, our project focuses on three primary objectives: identifying areas of high flood risk in Clarksville, analyzing change in tree canopy from 2001 to 2023, and finally, we wanted to evaluate the effectiveness of tree canopy as a flood risk mitigation tool. This is where our first and our second objectives kind of come together. So next slide, please. A variety of Earth observations were employed. To do this, we used Landsat's cluster of 5 through 9 in the National Land Cover Database product as an input to our model to assess flood risk. GPM iMerge was used to achieve precipitation totals for flood and / precipitation events of interest, and Sentinel-1 synthetic aperture radar was used in the process to derive surface water extent following a large precipitation event.
The picture on this slide is an overview of our methodology in two main sections. On the left, for our flood map package section in blue, is a workflow for analyzing flood risk in Clarksville. Utilizing Google Earth Engine, Python, and ArcGIS Pro for visualizations, our team utilized a flood model to determine where pluvial flooding may occur, what may be driving the increase in flooding within Clarksville. On the right, in the tree canopy assessment section, in green, is a workflow for analyzing tree canopy extent in Clarksville. Our team aimed to determine where the trees are, how they've changed over the years, and ultimately how they influence pluvial flooding to determine if they are a viable flood mitigation tool. Next slide, please. Thank you. Next, we'll get into the methods and results for the urban flood mitigation map package. So to assess flood risk for Clarksville, our group utilized it's a mouthful, but the Integrated Valuation of Ecosystem Services and Trade-offs, or the INVEST Urban Flood Risk Mitigation UFRM model. The INVEST UFRM is a widely used model to assess factors such as runoff, retention, and potential flood damage. These factors can provide an estimate of where flooding may occur. This model requires input data listed on this slide, which we won't cover all of at the moment. Optional inputs also include built infrastructure, building footprint files, as well as damage loss tables as an optional output to get potential building damages for a flood event. So we ran the model with multiple land cover years from 2001 to 2024. For every land cover year, we also tested various rainfall value ranges, ranging from about 100 millimeters to 300 millimeters. The purpose of running these tests is to see how both land cover change and different precipitation values influence runoff and retention across the city. The output of the model gives us data regarding runoff, retention, and potential economic damages. These statistics were then compared to one another as we hope to pinpoint if there are any variables that showed a relationship as we change precipitation and land cover throughout time. I think you're muted, Don. Yeah.
Sorry. Pictured here are two outputs of running the model with the 2023 land cover and 279.4 millimeters or 11 inches of precipitation. The runoff is pictured on the left and the retention is on the right. These maps are calculated using land cover type and present soils because the model is interested in the permeability of those variables. Runoff tells us where water is flowing and pooling, while retention tells us where water is being absorbed. With that being said, we can see an inverse relationship between these two variables. Notice in the downtown area, we see high runoff, the darker blue colors, which is expected because there are higher amounts of impervious surfaces in that area. In correspondence, moving to the retention side, we see low values in this downtown area, meaning little water is absorbed into the soils due to the lower tree canopy cover and high development in that area. Okay, next slide, please. So the team performed a series of experiments holding everything constant but land cover for different levels of precipitation. From this assessment, we were able to create statistics showing the correlation between Clarksville's land cover and runoff over time at different levels of precipitation. The x-axis shows different NLCD years that we tested in the INVEST model. The left y-axis shows the total runoff summed up over the entire area of Clarksville, and the right y-axis shows the total land cover pixel count. A clear relationship can be seen for all the precipitation events tested. As developed areas increase and forested areas decrease, runoff, and therefore flooding, also increases. Though this relationship holds true for all the precipitation values tested, it's important to note that as you increase the amount of precipitation, this relationship is a lot less impactful. Once you reach higher levels of precipitation, the area floods regardless of the amount of forested area present. Again, though, in all cases, higher forested areas correlate with lower runoff. Okay, next slide, please. All right, so to produce more accurate results for our flood risk analysis, our team made several enhancements to this model. We modified the source code for the flood model to accept a precipitation raster from GPM iMerge, a NASA Earth observation product that can estimate precipitation amounts. This precipitation raster allows for different rainfall values to be applied to regions of Clarksville instead of the uniform coverage the standard model assumes. We also derived higher resolution watersheds from a digital elevation product. Lastly, our team performed further processing of our soil input data. These enhancements to the urban flood risk mitigation model allow for a more accurate representation of how runoff and retention may manifest during a flood scenario. Next slide, please.
So we utilized our enhanced INVEST UFRM model to examine historic flash floods for the city of Clarksville. This was done by attempting to emulate the conditions of known flood events with land cover appropriate to the year and GPM iMerge data specific to the event. These case study runs provided higher accuracy output than the standard UFRM model. For this comparison, we used satellite data from Sentinel-1 synthetic aperture radar sensor. This sensor is frequently used to determine surface/flood water extent following a flood event, and our team did so by utilizing the HydroFloods Python package from Severe. This package allowed us to easily utilize the Ejatsu thresholding method to determine real-world flood extent in order to examine runoff and land cover characteristics for the area considered flooded. Next slide, please. So this slide shows a result sample for a storm event from April of 2025, where roughly 150 millimeters of precipitation fell over a several-day period. Sentinel-1 scan from a few days later was used to derive floodwater extent, which is shown in red on the maps on the left, overlaid on a runoff map from the model on the top, and overlaid on a land cover map on the bottom. This flood extent was used to extract statistics for runoff and land cover that give some insight into how the UFRM may correlate, and this can be seen in the tables on the right side. For runoff, we can see an average value. Runoff, we can see an average value of about 108 out of a maximum of 180 millimeters for the area considered flooded by the Ejatsu method. This implies a slight but non-significant correlation between runoff and surface water extent. For the land cover class table, we can see that alongside cultivated crops and agriculture at the top, several developed land cover classes are considered heavily flooded using this method.
Okay, so now we're going to move on to our tree canopy cover assessment. Okay, next slide. So for our methods, we chose NLCD tree canopy cover because it isolates tree canopy, unlike other data sets that account for all types of vegetation. By taking a difference of our two maps, the modern 2023 map and our historical 2001 map, we produce a net change map. Later, we compare this result to our urban flood risk mitigation model output. Okay, next slide, please. Okay, so our first urban canopy assessment results are derived from the most current Clarksville tree canopy cover map. This map describes tree canopy cover as a percentage cover over on a gradient from 0 to 99%. Green symbolizes dense vegetation cover, while tan represents no canopy cover. When averaging all the pixels within Clarksville, we find the overall canopy cover is 27.5%. By analyzing this map, we can see that high canopy cover follows the Red River, such as in the Austin P recreational area. Okay. Next slide, please.
So here we can see the results of TCC change from 2001 to 2023. Areas of loss are shown in red, and areas of gain are shown in green, and areas of minimal change are shown in yellow. The larger red areas are typically all land cover conversions from forested to developed, with many of these consisting of new neighborhoods or shopping centers where clear cutting took place. From this data, we've calculated a roughly negative 0.94% net change in canopy over the study area, with a 23.8% loss. On the other side, in terms of gain, we can see some areas such as the northern border of the study area does show a relatively large gain in TCC around these developments, and a general scattering of green showing an extended canopy or expanding canopy throughout the study area. Next slide, thanks. We'll now move into the discussion of our results by combining our outcomes from the model and the TCC assessment. So here we can see the change in runoff as an output from the INVEST UFRM on the same time scale as the TCC change map from 2001 to 2023. Areas in red on the right map show a gain in runoff, areas in blue show a loss in runoff, and areas in gray show minimal change. We can see here that nearly all of the major areas of TCC loss in red on the left are visible in the gain in the runoff map on the right. These are our areas of primary concern involving flood risk and TCC loss. Inversely, we can also see that the areas on green on the left representing TCC gain are visible on the runoff change map in blue, showing that areas of TCC gain seem to correlate with a reduction in runoff. There are numerous larger pockets of runoff, such as the large blue, the blue C shape in the center of the map. This is not reflected as TCC gain in the map on the left, so this would point more to nuanced land cover changes resulting in a loss of runoff beyond just the presence of trees.
So for our TCC versus retention, we compared our tree canopy cover map to our INVEST outputs for an event of 100 millimeters of rainfall. We summarized our results to custom fishnets to get more accurate results than what can be produced by watersheds or wards. To the left, we have our 2023 tree canopy cover map, and to the right, we have the runoff retention map from the 2023 land use land cover assessment. Spatially, we can see that higher tree canopy cover areas generally correlate with areas of higher retention, which indicates the ability of trees to mitigate flooding in Clarksville. Okay, next slide. Okay, so then we created a bivariate map to combine the tree canopy cover and retention into a single map. The darker blue-purple values indicate areas where tree canopy cover presence and high retention overlap. The 2023 map, our most current tree canopy cover map with 27.5% tree canopy cover over the study area, positively correlates with retention during this 100 millimeter precipitation event. Looking at bivariate maps for heavier levels of precipitation, the team also found that this relationship weakens as precipitation gets more severe because permeable surfaces can only retain so much water before cooling. Okay. Next slide, please. All right. So for our limitations, errors, and uncertainties, the urban flood risk mitigation model is a very accessible model for decision makers and stakeholders, but it oversimplifies the hydrological processes and does not consider elevation data. Additionally, the soil hydrology layer that we selected for the INVEST model requires additional processing to ensure a consistent output. Next, the GPM iMerge is an accessible and feasible precipitation input into our enhanced model, but comes with limitations regarding the level of data available, with the most accurate data product taking at least 3 months to process. This offset can cause larger value discrepancies with more recent precipitation events. Finally, Sentinel-1's 12-day scan frequency makes it very difficult to capture pluvial flooding using Sentinel-1. In addition, the HydroFloods Python package and accompanying surface water detection method comes with large amounts of settings that would require more fine-tuning depending on the study area. Next slide, please. All right, so future efforts could incorporate CHIRPS or NOAA's NextRad radar data, which may improve the accuracy of the precipitation input. Overall, whether INVEST urban flood risk mitigation models should be used going forward depends on the goals. Unmodified and modified INVEST urban flood risk mitigation model is good for investigating how different land cover types, including tree cover, impact pluvial flooding, which is what this project kind of focused on. The modified INVEST urban flood risk mitigation model is better than the unmodified at modifying the behavior of any given excuse me, of any given precipitation event due to the input of a raster. The unmodified and modified INVEST urban flood risk mitigation model is not the best for exact hydrological processes. So if you care about exactly where water is going to accumulate, it may not be the best model for you. I'm going to let Kathrine speak on the partner implementation side of things.
And talking about doing the partner implementation on this, we have several partners that are interested in working with us. Replant Clarksville's is a newly developed tree planting effort for Clarksville. There is interest in all our studies, and we would like to share with them some of our work. We would also like to share Regional Planning Commission and City Council. And we feel if we bring all these people together, it will contribute to our decision making for basically our tree planting prioritizations, our urban planning decisions, and our resilience planning, and making sure we align with our state and federal sustainability goals also.
Thank you, Kathrine.
So our team came to the following conclusions to wrap up. Tree canopy cover is currently 27.5% of the entire area and has decreased by 0.94% within the past 22 years. And as Clarksville's canopy decreases and precipitation events become more aggressive, canopy cover can become less effective as a flood mitigation strategy. Land cover composition directly correlates with runoff and retention for the study area. And tree canopy cover and the INVEST UFRM flood model combined indicate that overall flood risk is rising in Clarksville due to a loss of canopy and increase in impervious surfaces. So some acknowledgements. The Clarksville Water Resources team would like to thank our partners, the City of Clarksville and the Tennessee Urban Forestry Council. Also wanted to thank our science advisors of Dr. Grafika Flores-Anderson and Timothy Mayer, as well as Dr. Kenton Ross. We'd like to thank Christina, our node lead, and the rest of our team who couldn't make it today, as well as our other teammates from our Marshall node. Thank you.
All right. Thank you so much, everyone. Christina, Betsy, Drew, Tana, Kathrine. I know this was a lot, 2 different studies to fit into a pretty short time period, and just so much data to go into. And at least to a question that I have, I think for Kathrine, or really for any of the participants. And while I'm doing this, feel free to input your own questions into the chat. We'll hand this over to Katie shortly to facilitate that and read off your questions. So feel free to input those. But one question I have for you, Kathrine, is how do you now go and translate these studies and talk to folks at community events or city officials and sort of translate it into them in a way that's persuasive and compelling and lands? So I'm sure that's a challenge, but would love for you to share more about that.
Well, it's going to be a slow process. There's not a lot of people that understand GIS and what we all just have viewed. Thanks to the developed team, I think the observations for the stormwater mitigation project and the urban island heat project, they've identified basically the high risk runoff areas. The satellite data, helped pinpoint the impervious surfaces. The tree canopy data was overlaid to find gaps where the trees need to be added to, reduce some of the surface flow. And it's promoted nature-based solutions. So basically, the team showed us, how urban forestry, planting more trees or protecting existing forests, could actually help slow water flow, basically enhance our filtration and reduce the strain on our stormwater infrastructure. So I believe by using these spatial tools and maps, the city planners, we could persuade them to use, possible tree planting or conservation areas and integrating to, these stormwater master plans. Like I said, we'll get the word out there. We do a lot of continuing education, and I've got plenty of help. Carla King over at Urban UT Extension, she helps me with a lot of downtown stuff, and we've got some more folks that are more interested in it also, and I believe we'll eventually have to do some goals to improve our canopy rates, but we're going to try.
That's right. Thank you, Kathrine. All right, I'm going to hand this over to Katie, and she is going to facilitate the Q&A, and then for those of you who are here seeking CEUs, at some point here before the end of the call, we'll also put up a QR code for you to scan and to record your attendance. So, Katie, I'll hand it over to you.
Great, thank you, Kevin. The first question is for Tana. They said a reference was made earlier to housing development being a source of eventual heat gain. Why did the restoration priority mapping not identify higher priority intervention and restoration in these areas? Is it because there is low capacity there for restoration, or are there other factors that caused these areas not to be prioritized? Does this also mean that preservation and focus density is the best preemptive solution? And let me know if I need to repeat any of that.
Okay, thank you. Could you, I guess, clarify, is it the socio-environmental map or the just regular, I guess, environmental restoration map? So I know we did have two.
I'm honestly not sure which map they're referencing with this question. I'm seeing if they put anything in the chat.
Okay. I guess, Christina, could you also kind of go back to those restoration maps?
Yeah, of course.
Thank you.
And then we have this one.
Yes. And then there's the one before it too.
Okay.
Yeah. Okay. I mean, I can go ahead and kind of speak while we're waiting. I guess I'll speak out a little bit on both, but so for the environmental restoration priority map, it did weight NDVI as and the urban heat island at 35%, and then the impervious surface cover by 30%. So it could just be like, I would assume that tighter packed areas are going to have lower tree canopy cover, so the NDVI is going to be lower, and they're probably going to be experiencing higher urban heat island effect, and the impervious surface cover is going to be high. So those, I think, are the more weighted at more moderate levels, because there's still some tree canopy. Oh, it was the environmental, the one we're on now?
Oh, yes, the environmental restoration
awesome.
map.
So those areas are still weighted relatively higher than all like other forested areas with like mild and moderate levels, but they still do have some trees compared to like along like roadways and like at these very busy more industrial areas like in downtown Clarksville, and then like over there where like the mall is and Walmart and bigger development areas. Larger development areas just have lower canopy and lower and higher impervious surface cover, and so they're weighted with just the environmental factor weighted a lot higher as a result. Whereas like some of the developed areas they're still like experiencing the urban heat island effect, and with like higher development, they're causing the urban heat island effect to increase. But compared to like already developed areas, they're not experiencing it nearly as high. So I hope that answered the question.
Thank you. And then this question is for Kathrine. Kathrine, you kind of already addressed it, but what plans does Clarksville have for using the information in this report, and how expensive or difficult would it be for an organization to generate a similar report for all of Montgomery County?
That's a good question. In reference to Montgomery County, I know Planet Geo could probably do maybe some tree canopy studies, maybe some heat mitigation, but I don't think it would be anywhere near what these students did for NASA. I think what they did was amazing. By combining both projects, I mean, they painted basically a comprehensive picture of how urban forests play a dual role. And I think it will benefit Clarksville once we share it, and by increasing our canopy with everyone that is involved.
Thank you. And real quick, I'm actually going to, Christina, would you mind to stop sharing your screen, and I'm just going to pop up the QR code real quick for people who need to hop off this call. Would y'all mind staying on to answer a couple of more questions? Okay, great. Someone asked if we could revisit, or if okay, let me start over. They asked, can you revisit or explain the tree canopy cover decreasing by negative 0.94% within the past 22 years?
Yeah, I jumped the gun a little bit there in the chat, but yes, that number, I might have misspoke when I said it out loud, but overall Clarksville, the study area, according to the NLCD TCC, the tree canopy coverage data set, has shown a decrease of 0.94%. That is the net change, so it's a net decrease over the 22-year study period, and it includes both gains and losses. So it's not as like significant as you'd probably expect, because there were a good amount of like gains from different kinds of land cover conversions throughout the time period.
Thank you. Next question. This is for Kathrine. Are tree surveys required before developers clear land? It seems throughout development sites in Clarksville, trees are completely removed and ornamental invasives are replaced. Does a tree ordinance exist to hold developers accountable? If it exists via tree replacements or credits, must species match removal? Oh, Kathrine, you're muted.
There is a city tree ordinance that is governed by the tree board. We do have that. That is one set of rules. And also the Regional Planning Commission also has a landscape ordinance for developers. So when you are developing, you need to follow the landscape ordinance by the Regional Planning Commission. And there are people that do come out and actually observe what you're doing. They do take notes, and there's a lot of forms I know you have to fill out in reference to trees that you want to keep and trees that you want to remove. And I know that the two are two entirely different sets of rules on the rule book. And we're actually working to possibly take care of those rules. But you got to do it a little bit by little bit. You can't, reinvent the wheel overnight. Take some time.
All right, next question. And also for anyone who needs to hop off, because I know it's 1 o'clock, if you need to leave, just make sure, like I said, that we have your name, that you're registered with, and that you use the QR code. But if it's okay with y'all, I'm just going to ask these next couple of questions. In areas with extremely high, sorry, let me read this sentence first. In areas with extremely high impervious surfaces, is it better to pack the green spaces with canopy to attempt to reclaim some of the impervious surfaces, even if most of the area is privately owned?
I think that that's a really good question. If I had to kind of take like a guess at it, I think a lot more work would need to be done for me to be like concrete with any kind of conclusions. But just kind of, I guess, speculating a little bit, I would say for the urban healing effect kind of side of things, I think denser canopy patches are more effective with localized cooling, especially like in those areas with higher heat. And then for flooding, I would say more scattered um, is more effective for reducing runoff. So I guess for long-term resilience, kind of combining the two, um, that would be kind of my thoughts. I don't know if anyone has anything else, but that's my speculation.
Okay, and let me see here. This is more of a comment than a question, but one person put in the chat, when developers clear land for a building, they typically bulldoze all vegetation instead of evaluating high-value trees to save. Politically, the developer replaces the removed trees by number but not size. And they said that laws should be written that require replacement with larger trees, not the small saplings that are currently used. I don't know if any of y'all would want to speak to that.
I know that the tree ordinance states that we should, if our tree is removed, it doesn't state where, just other on public property, that we have a duty to put back those trees on a per caliper basis, 2 caliper basis per caliper, 2 caliper basis on per tree, I think is what it is. So, but yes, we want to save the big trees, but we have a lot of developers that don't want to save the big trees. And it's just, something that it's going to take time to get people to understand the value of trees, what they're worth, what they do for us. If people quit considering a tree or it, and actually consider them a living part of what we need for the city of Clarksville, only then will they be able to understand what the needs are and how to take care of the city by implementing these trees and large trees and keeping them.
And I believe this is the final question, but someone asked, this is before the webinar, but they said that they're interested in the data sources and analysis tools that were used and if they're open to the public.
I can go ahead and take that question. So as shown in the presentation, the teams do put which satellite data they utilized. Throughout the term, teams did work on a technical report and presentation. The presentation has been or will be shared with Kathrine and Kevin, and those are export control. Those are free for y'all to do what you would like. So perhaps disseminating that within this network would help kind of further give more context to where to access these data sets, but the technical paper, it is still under NASA export control review. That one will have in way more detail where our participants, like what websites, how they download it, where they process it and such. So again, once that is out of export control, it would be shared with Kathrine and Kevin. And again, both of you are free to do what you would like with that export controlled technical report. So perhaps a good source would be public dissemination within your network. And that should be a good source for where to access these data sets.
All right, well, let me see. I mean, we're coming up. It's past 1:05 now. I feel like we should probably wrap it up. So.
Yeah, we'll go ahead and wrap it up. But thank you all for staying past a few minutes. Again, all the NASA Develop folks, Christina, Drew, I know had to hop off, Tana, and Betsy, thank you again for joining us. And thank you for all the attendees who join us every month. Real quick, just a few other events to look forward to. Next month, we do have another webinar with Lee Rumble, who's an extension agent in Knox County in Tennessee, covering common tree pests in the Southeast, and that'll be September 18th. We also have next week, Wednesday through Friday. It's not too late if you are an ISA certified arborist or a certified arborist candidate looking to take the exam. We have a prep course in Nashville next Wednesday through Friday. Not too late to sign up. And then lastly, our annual conference is in Chattanooga, November 13th and 14th. If you're in the region, we'd love to see you there. It's a really good time. We have some really fun field tours scheduled this year to get everyone out of the classroom setting. So we're really excited about it, and hope to see you there. But until then, take care, and we'll see you next month.